3.1a, the addition principle. In this lecture, we're going to go through the basics of algebraic equations and what it means to have a solution to an equation. So, to start off with, the definition of an equation is an expression stating that two sides are equal. That's all it means. So, an equation might be x equals 3. This means that x is equal to the quantity 3. A solution to an equation is a number that we can replace a variable with and end up with a true statement. So let's check this out. Say we had the equation x plus 1 equals 2. Well, if we replaced x with 1, so let x equal 1, then we could see that we would end up with a true statement because 1 plus 1 is equal to 2. That's a true statement. So x equals 1 is a solution to this equation. So how do we solve equations without just guessing and checking at random? That would take a long time, potentially. So when working with equations, we always adhere to something called the golden rule, or the golden rule of algebra. And this is what you do to one side of an equation, you must do to the other. You must do to the other. For it to remain an equal statement, we have to do equal things to both sides. So using this is exactly what the addition principle states. The addition principle states that we can add equal quantities to each side of an equation. That's what the addition principle states. So we can think of this like a scale. An equation is like a scale. So let's draw a picture of a scale here. Have the equal sign here. So say we had 2 equals 2 here. We would agree that this would be a balanced scale if we had 2 on each sides of the scale. Now if we added something to both sides with the same weight, say 1 pound to each side, the scale would remain balanced. That's all the addition principle is saying, is that we can add equal things to the same or to opposite sides of an equation, something that's already equal, and it will remain equal. Well, how is this useful to us? Let's go through an example and we'll see. So the first example, solve x minus 4 equals 6 for x. So here's an example of an algebraic equation, something with a variable, and we'd like to know what values of x does this equation true for. So if we imagine this like a scale, we have a scale here. On one side is x minus 4 and the other is 6. This statement says that this is an already balanced scale. So we can add something to both sides as long as it's equal. So I have x minus 4. Why not add 4 to both sides? So how about I add 4 to both sides? And we'll see what happens when I do this. Looking at the left side, 4 plus negative 4 is just 0, right? So the 4's cancel. And 6 plus 4 is 10. So now this becomes x plus 0 equals 10, or just x equals 10. Now we have a solution to the equation. X equals 10 will work for the equation. Let's check this. If I replaced, so starting with my original equation, if I replaced x with 10, x minus 4 is 6. 6 equals 6. This is a true statement. Therefore, x equals 10 is a solution to my equation. So let's try this again without the scale analogy. Solve a minus 6 equals 18 for a. Well, I want to get a by itself. So why don't I add 6 to both sides? And move downwards. So negative 6 plus 6 is 0, so these cancel. And a equals 18 plus 6 is 24. So a equals 24 is a solution to this equation. It's as simple as that.